All right, guys, so before we get started, are there any questions on any of the assignments thus far?
No, but I have two
Well, we still have time to get them done.
just before the test.
Yes. So I think that one's finished. Yeah, so I would still finish it up because it's still not a zero until the end of the day of the test. So we're still looking at possibly next week or the week after.
Sweet.
Yeah. So, all right, guys, so what we've done so far is we've gone over factoring, we've gone over solving by factoring, we've gone over solving by graphing and the square root method, and all of this has been revolving around quadratics. And what we just went over is our negatives, our I, these imaginary numbers. Now, the square root of a negative number property. If r is a positive real number, then the square root of negative r is going to be equal to I square roots of r. So if we have a real number and we put it inside of a radical and we have the opposite, the negative of it, the negative is going to come out as I, and then we simplify whatever the radical is. So if we said that here, we just pick a value for r, we say r is 9. So by this property, the square root of negative r is going to be I square roots of r. So for us here, it's going to be the square root of negative 9, which we would say is I square roots of 9, which we can then simplify to 3i. And then the opposite is true. If, by the first property, it follows that if we square it, if I take I squared of 9 and square it, we will get back to negative 9. All it says is that we can take the square root of a negative number and get a value with I. That's all that's saying. So, if we look at this in context of a problem, like the first one here, x squared plus 4 equals 0, we can solve this. Now, out of all the methods that we have for solving, graphing, factoring, square root method, the only one that's going to work, especially with imaginary numbers, is our square root method. Now, because we don't have a middle term, first thing we can do is subtract 4 from both sides. 4 minus 4 gives us 0, leaving us with x squared.
I need the following students to report to room 16. Rance Gifford, Lauren Hancock, Addison Jeeks, Destiny Jones, Jacob Martinez, Destiny Olenek, Brooklyn Williamson, Hanny Yang, Melanie Yang.
Now at this point here, we can take the square root of both sides. Now on the left-hand side, our square root of x squared is going to give us x. Yep. Equals plus or minus. So we have to take the square root of negative 4. Now, square root of negative 4. We know the negative is going to have to come out as I. And what that leaves us with is the square root of 4 that we still need to simplify. Now, luckily for us, the square root of 4 does simplify nicely, telling us that it is 2. Now, because it simplified nicely, our square root of negative 4, we could have put that straight into the graphing calculator. Second square root, negative 4, it would have told us that it is indeed 2i. And because we took the square root of both sides, we have to put the plus or minus, telling us that x squared plus 4 is equal to plus or minus 2i. Is our final answer. So we can actually start solving these with non-real answers. Because if we tried graphing it, x squared plus 4, delete everything else out of that, graphed it, it does not cross the x-axis, so we don't have real solutions, which means we can't graph it. Also means in our normal factoring sense, we can't factor it either. So we're having to use this square root method as the only method that's working for this here. X equals plus or minus 2i. Questions on this here? Now, as I said before, if we're not sure, we can always check it, and it seems odd that we can check it with 2i, because 2i squared plus 4 should equal 0. Now, we can actually check this in the graphing calculator. We can say parentheses 2i squared plus 4. And it'll tell us it is indeed 0. And the same thing is true for negative 2i squared plus 4. It is still 0. We can plug them into the calculator and see that 0 equals 0. And negative 2i squared plus 4 is 0. So they both work. Questions on this here? If we look at the next one, 2x squared minus 11 equals negative 47. Now, most likely, we're going to solve this by the square root method. We could try solving it by factoring or graphing. If we wanted to solve it by graphing, we would need to get it equal to 0. So we would add 47 to both sides. I wouldn't write this. Telling us that 2x squared plus 36 is equal to 0. 2x squared plus 36. Well, we see that it doesn't even show up on the graph. It doesn't cross anywhere. And even if we tried factoring it, we're looking at x squared plus 18. We don't have a sum of two squares formula that we've gone over that we can do. Now also, when we look at this equation, the only variable we have is x squared. It's our squared term, which means square root method works. The square root method only works if we have x squared, or the only place the variable shows up is inside a set of parentheses being squared. And if we use the square root method for this here, the first thing we need to do is get the squared term by itself. So we can add 11 to both sides, telling us x squared is equal to negative 36. Then we would divide both sides by 2, telling us x squared is equal to negative 18. And once we get the squared term by itself, we take the square root of both sides. Square root of x squared is going to be x is equal to plus or minus. Now we need to look at the square root of negative 18. 18 is not a perfect square. One of it is just knowing our perfect squares, because the perfect square numbers we have are 4, 9, 16, 25, 36, 18. That is not listed there. So it's not going to be a perfect square. But we do know that this negative is going to have to come out as I. We know that for a fact. And what that leaves us with is the square root of 18. And knowing that is nice, because square roots, the 30xs, the yellow calculator will do square roots nicely every single time. So I can ask it to find the square root of 18. It tells me it's 3 square roots of 2.
May I have your attention? May I have your attention, please? I need all sophomores to go to the library at this time. All sophomores go to the library at this time.
So that tells us that x is equal to plus or minus 3i square roots of 2. And that's it. Questions on this here? So really, especially with these imaginary solutions, these imaginary terms, square root method works well. As long as we have either the variable being squared only, we only have x squared, t squared, or the only place that the variable is going to show up is inside a set of parentheses squared. Because if we have one of those two options, we can use the square root method. It's going to work every time. But if we have a middle term, we have x to the first power, it's going to cause issues. We can't do square root method. So let's look at this last one here. Because if we're finding the zeros, we're trying to find out what value of x is going to make this equal 0. And as we've seen already, we could try graphing this, but unfortunately it's not going to cross the x-axis at all. And since the only variable is x squared, we can use the square root method. We can subtract 20 from both sides, telling us 4x squared is equal to negative 20. X is still not by itself. Our squared term is not by itself. So we divide both sides by 4, telling us x squared is equal to negative 5. Now that the squared term is by itself, we will square root both sides. Now the nice piece on the left-hand side, the square root of x squared is just x. Square root and square cancel. Square root of negative 5. Well, we know the negative has to come out as I. Now, since 5 is a prime number, it's just going to be the square root of 5. So for this one here, it's telling us that x is equal to plus or minus I square roots of 5. And that's it. So these three here aren't any different than what we've been doing with square roots in our square root method. It's just all of these here, our solutions are these imaginary, these complex terms. If it had been inside a set of parentheses, we would have solved for x, we would have added, we would have subtracted, and put that number in front, which would have really given us a full complex term, a real part, and an imaginary part. Questions on these here? Now, up to this point, we have not had a method. Out of all the methods we've had, graphing, factoring, square root method, that worked every single time, which is kind of an issue. Because it's in mathematics, in pretty much all the natural sciences, we want a method that works. It doesn't matter where we start with, it doesn't matter what we have. We need a method that's going to work every single time. Because even in geometry, when we talked about proofs, if we're trying to prove something's true or verify a formula, a theorem, we need to show it works for all. For us to disprove it, we need to show that it doesn't work for one. If we can find one case that doesn't work, it's not true. We want something that works for everything. So, we're going to start kind of delving into a method that does work for every case. Because really, and it's going to stem from the square root method. Square root method works if x squared is our only variable, or the variable only shows up in a single set of parentheses being square. Yes? So when we look at this here, I'm going to ignore the 100 for now. I want to factor x squared minus 16x plus 64. We're going to factor this. Now, there is no greatest common factor between x squared, 16x, and 64. So we'll have our two sets of parentheses with 3 spaces. Now when we find the sign, since the third term is positive, the signs are the same and match the sign of the middle term. Middle term is negative, so we have negative and negative. Factors of the first and third term. The first term is x squared, so the only factors are x and x. Now the factors of 64. I don't think I wrote over the top of that. 1 and 64, 2 and 32. 3 doesn't work, but 4 and 24, 16, thank you. 5 doesn't work, 6 doesn't work, 7 doesn't work, but then we have 8 and 8. We're going to use 8 and 8. And if we check this, x times negative 8 is negative 8x. Negative 8 times x is negative 8x, which does give us negative 16x. I know we're going kind of quick for this, but we get kind of how we got to this point, yes? What is interesting about how this is set up? Because we do have two things multiply together, but they don't equal 0, so I can't use the zero product property. But there is something interesting about our two factors. They are the same, yes? So if I have something multiplied by itself, two things being multiplied together that are the same thing, we can rewrite x minus 8 times x minus 8 as what? X minus 8 squared. Because when we square something, we're saying that it's being multiplied by itself. X squared minus 16x plus 64 is a special type of quadratic. We call it a perfect square trinomial. It is a perfect square trinomial because its factors can be written as a single set of parentheses being squared. That's nice, because if I have these perfect square trinomials, we can rewrite them as a single set of parentheses being squared. Now we can use the square root method, because the only place the variable shows up is inside the setting, this set of parentheses being squared, which means I just have to get it by itself. Then we can square root both sides. And on the left-hand side, the square root and square will cancel, telling me that x minus 8 is equal to, well, the square root of 100 is 10. So even though we started out with an equation that had a square term, a middle term, and a constant term, we're able to factor it, get it to a perfect square trinomial, or have it as that. Single set of parentheses squared, so we can take square root of both sides, and then solve for x. We can add 8 to both sides, telling us x is equal to 8 plus or minus 10. Any questions on this so far? Now, since 8 and 10 are like terms, we are going to have to simplify, because we can definitely find 8 plus 10, and we can definitely simplify 8 minus 10. 8 plus 10 tells us that x is 18. 8 minus 10 tells us that x is negative 2. Questions on what we did here? We kind of understand, may not fully understand, but we kind of see what's nice about this, yes? Because if that left-hand side, if we can get the x squared x in our constant term, those three numbers, to be a perfect square trinomial, if I can get them set up so that we can factor it to a single set of parentheses being squared, it doesn't matter what's on the other side. It could be 0, it could be a positive number, it could be a negative number. At that point where we get that single set of parentheses being squared, we can use square root method and we can solve. That gives us a way to be able to start solving any quadratic. Because once we get here, it doesn't matter what it is. We can take the square root of both sides and solve. That's what's nice about this. Now we're going to look at two more, this one and the next one. X squared plus 4x plus 4 is a perfect square trinomial. Since the third term is positive, the signs are the same and match the sign of the middle term. So we'll have plus and plus. Factors of x squared. Only ones we have are x and x. And the factors of 4 are 1 and 4 or 2 and 2. Now we're going to pick 2 and 2 because, again, we want this perfect square trinomial. We want to be able to write it as a single set of parentheses being squared. And if we do check to make sure, x times 2 is indeed 2x. Positive 2x. 2 times x is also 2x. 2x plus 2x does give us our middle term of 4x. X plus 2 times x plus 2. We can say that's the same as x plus 2 squared. Yes? Now what do? We square root both sides. And on the left-hand side, the square root and square will cancel, leaving us with x plus 2. On the other side, we have the square root of 36. And the square root of 36 is indeed 6. Since x is not by itself, we would subtract 2 from both sides, telling us x is equal to negative 2 plus or minus 6. Now again, at this point here, we'd be done as long as we can't add negative 2 and 6 or subtract negative 2 and 6. Well, we can, yes. Because negative 2 plus 6 is going to be 4. And negative 2 minus 6 is negative 8. So we get 4 and negative 8. Now on this one and the last one, did we get integer answers? Well, yeah, negative 2 or 4 and negative 8 are integers. There are nice numbers, positive, negative numbers. On the last one, we got, I think it was 14 and negative 2. Negative 2 and 18. Those are integers again, yes? So could we have gotten this one or the last one equal to 0 and graphed it? Yeah, that would have worked just fine. And I think we're starting to get the feeling of how this works, yes? But what is the key hitch to all of this? That what? This has to be a perfect square trinomial. That x squared term, x term, and that constant term have to be factorable in such a way that we can rewrite it as a single set of parentheses being squared, yes? Is every equation quadratic going to be able to be rewritten as that? Well, no. If we can make it so that it is, that would make things much nicer, yes? Well, we're going to skip over this because I feel like we kind of got this, and that's what completing the square is. This is the first method that will work for every single case, and yes, you don't have that down yet. But completing the square is the first method that we will have that we will be able to solve every single quadratic. And the big piece is making it so that the quadratic, our x squared and x term, and our constant term is going to make a perfect square trinomial. And that's where this completing the square term comes from. Now the biggest case, or part of it, is actually making a perfect square trinomial. Because for any given x squared and x term, we can make a perfect square trinomial because c, the constant term, part of this, is equal to b over 2 squared. So if I have a squared term with a being 1, so an x squared term, and a middle term, our term with x, I have x squared plus bx. No matter what b is, I can find a value of c that will make it into a perfect square trinomial using this formula here. C is equal to b over 2 squared. So when we look at this here, x squared plus 14x plus c, we want to find this value of c. Well, that value of c is equal to b over 2 squared. Now, b in our case is what? This here, it would be 14. Specifically, it's going to be positive 14. If it had been x squared minus 14, b would be negative 14. So b is 14. Now, the value of c that we want is equal to the value of b over 2 squared. Well, we said the value of b is what? 14. So c is equal to 14 over 2 squared. Now, 14 divided by 2 is 7. Then we just need to square it, and 7 squared is 49. So we're saying that our perfect square trinomial that we would want having x squared and 14x would be x squared plus 14x plus 49. So even though it didn't give me a c value, I now know the c value that would make it a perfect square trinomial. That lets me be able to rewrite this as a single set of parentheses squared. So we are going to factor it. We're going to factor x squared plus 14x plus 49. Now, there's something really nice with this here. So a is always going to be 1. The number in front of x squared is going to be 1. If it's not, we're going to make it be 1. So when we factor it to this here, the number in sign that's going to go inside this parentheses with x is going to be the number in sign we had for solving for c before we squared it. So with c, we had positive 14 over 2, so we divided it and got 7, positive 7, squared it to get 49. So the number inside the parentheses before we squared it is positive 7, yes? So x squared plus 14x plus 49 is actually going to factor to x plus 7 squared. It tells us what it is. Now, if it had been x squared minus 14x, we would have still got 49, because negative 14 divided by 2 is negative 7. Negative 7 squared, negative 7 times negative 7 is still 49. But our parentheses would be x minus 7 squared. Questions on this here? So again, the reason this is nice is it doesn't matter what equation we're given. We can make it into a perfect square trinomial. We can make it so that it is a single set of parentheses squared and solve from there. So if we look at the next one, x squared plus 8x plus c. Now again, we said c is equal to b over 2 squared. And our value of b in this case is what? 8, and it'd be positive 8. So to find the value of c, that would make this a perfect square trinomial, we would have to put 8 in for b, giving us 8 over 2 squared. Now, yes, at this point here, we could plug that whole thing in the calculator. We can say parentheses 8 over 2, close parentheses, squared. But I would do the division first, because the number inside the parentheses before we square it will be going into it as our factors. And 8 divided by 2 is 4, and 4 squared is 16. So that tells us that our perfect square trinomial would be x squared plus 8x plus 16. And when we factor it, to a perfect square trinomial, we'd have a single set of parentheses being squared, and we'd have x. And the number that goes into the parentheses with x is the number inside the parentheses before we squared it to find c. And it would be 4. And since it's positive 4, we're going to say x plus 4. Let's do it with our next one, our x squared minus 2x plus c. So what's the value of b? It'd be negative 2. It's not just 2, it's negative 2, because we have minus 2x. Now, negative 2 divided by 2 is negative 1. Negative 1 times negative 1, we can just plug that in, is going to be positive 1. Telling us that our equation is x squared minus 2x plus now we would need to factor x squared minus 2x plus 1, and we could do the method that we've been doing for factoring two sets of parentheses with 3 spaces. Signs are the same, work through that whole thing here, but it works out that the number that goes inside here is the same as the number before we squared it to find c, which is negative 1, telling us that this here, x squared minus 2x plus 1, factors to x minus 1 squared. Questions on this here? We can say this is really nice. This is really neat that this works this way every single time, no matter the numbers. Especially if we look at 6. Or this one here, x squared minus 9x plus c, our middle term, our value b is what? Negative 9. Does negative 9 divide by 2 nicely? No. And especially with these here, when we start solving, when I'm starting to say nice, I mean it divides evenly. If it turns it into a decimal, at this point, especially with quadratics, I'm going to leave it as a fraction. As much as we dislike fractions, fractions are going to work nicer and better than decimals. Especially if we're having to take square roots of decimals, it's easier to take square root of a fraction, or having to square decimals. Now at this point here, negative 9 halves, if finding the value of c, this does not divide by 2 nicely, square it. We can just plug it in, parentheses, negative 9 over 2, close parentheses, squared. And it'll tell us that it's 81 over 4, 81 fourths. Which means that our quadratic is x squared minus 9x plus 81 fourths. Now, if we use the methods that we started this chapter with for factoring, this would be quite challenging because we're trying to find the factors of 81 fourths. We don't. Because again, as I've been saying, the number and sign that's going to go inside that parentheses when we factor it is the number and sign inside the parentheses before we squared it to find c, which is negative 9 halves. Yes? So our factors is going to be x minus 9 halves squared. It gives us a nice, easy way to factor this here. Questions on this here? So we kind of feel comfortable with this here. Now the question is, why do we even care about the 81 fourths if this will tell us how to factor it? Well, what did we do here? We added that to one side of the equation. Yes? Because if we add something to one side, we're going to have to add it to the other. So we need to know what actually c is to be able to keep the equation balanced, but it also does tell us how to factor it and solve. This is the key point. Being able to do this for solving by completing the square. But we'll go over this here again tomorrow. That's all I want to cover today. Is really seeing that, one, there is a way to do it for all of them, but two, getting comfortable finding that value of C in the factors. So 3 and 5 are what we started off with. That left-hand side, the x squared, x in a constant term is already a perfect square trinomial. So x squared minus 8x plus 16 equals 25. We can factor the left side into a single set of parentheses squared and solve from there. And then 11 through 18. It wants you to find the value of C to make a perfect square trinomial and then factor it. So exactly what we just did on those last 4 problems is all you're doing for 11 through 18. Because once we get comfortable finding the value of C, completing the squares is going to be kind of nice.